Hola clase, today we are learning to transform complex numbers between rectangular and polar forms. And as usual, I would give you a how-to guide and then make an example together. Now, before we do all of that, remember that you need to know a couple of things. First of all, to identify your complex numbers, that they look as an a plus bi, and remember that's equivalent to call them x plus yi if you want to use something that looks more like coordinates. Then you need to be familiar with the use of Pythagoras theorem and trigonometry to know where things are coming from. Now, all of this comes from the fact that our complex numbers are two-dimensional numbers. They have a real part and an imaginary part. So any complex number set is going to have a real part that we call A and an imaginary part that we call B. But at the same time, because this is a vector here that has a modulus and an angle over the horizontal. What that leaves me, it's actually two ways of referring to the same complex number. One, what we call rectangular form, and the other, what we call polar form. Rectangular form, it's the one in which I call A the real part of the number and B the imaginary part of the number. So we refer to it as A plus bi. Whereas the polar one, let's make a line there to divide it. It's the one in which we talk about it as a vector. So that has a modulus, which is r, and an argument, meaning an angle, and that allows me to call the number r theta. So now for the how-to, it's going to be different depending on what I want. So we put a 1 in both sides. If I've got a rectangular form, I want the polar, the modulus, it's going to be this distance here, which is the hypotenuse of this right angle triangle. And the argument, this angle here, always measured from the origin. This is going to be the adjacent, and this is the opposite one. So I can come here and transform using a plus b. The modulus is a squared plus b squared. The argument, it's the inverse of the tangent between now b over a. If what I want is the rectangular having the polar, well, using trigonometry again, this is the horizontal projection, so it's going to be r cosine of theta, whereas this part here is the vertical projection, so r sine of theta. So let's put it in here. A is going to be r cosine of theta, whereas b is r sine of theta. That leaves me with a number, complex number z, which is a plus by, or r cosine of theta plus I sine of theta. And instead of using the whole thing, when we refer to it as a polar, we just use an acronym with these three letters here. So we call it r cis of theta. And it's the same number all throughout. Okay, let's see that in an example. First, they want me to convert one rectangular number in the polar form. So from here, I simply need to identify the A and the B and use them in the conversions we know. So the modulus are, it's A squared plus B squared, the square root of all of that. So in our case, square root of A, that's a 4, plus square root of B, which is a 12, the square root of that, it's 4. And theta is the inverse of the tangent of B over A. So in our case, inverse of the tangent of B, the signs are important, minus 2 square root of 3 over 2. And signs are important because this number has a positive A and a negative B. It's here in the 4th quadrant. So the angle, the argument is going to be negative. If you do that, that gives you minus pi thirds. So we've got it all. So I can come here and say that 2 minus 2 square root of 3i is the same as 4 cis of minus pi thirds. We've got the first one. Let's box it so we can find it. Now we're going to make a second example. Now in the other direction, they want me to convert a complex number in polar form to rectangular. So again, I need to identify the parts. This is the modulus and this is the argument. So I can come here and go, okay, A is r cosine of theta, which is going to be square root of 2 cosine of pi fourths, and B is going to be r sine of theta, which is going to be square root of 2 sine of pi fourths. And now if we remember from our trig, actually the sine of pi fourths and the cosine of pi fourths are the same, which are square root of 2 over 2. That gives me that both these two things are 1. So I can come in here, and this complex number in polar form is the same as A1 plus BI. I'm not going to write the 1 plus I. Okay, we boxed it so it's easy to find, and we're done. Now it's your turn to go and practice. Thanks for watching.